Okay, I think we're rolling. Okay. Um, I've received a lot of emails about the claim that I make that our web server is able to process 50,000 requests a second. People don't believe me. People tell me that I'm full of crap. That's literally one of the emails I received from one guy. He says that it can't happen. That's too fast for an IIS to give you that many requests a second for the dynamic site. And I want to clarify a few things. First of all, I'm not using IIS at all. I'm using WAVE Server. Okay, WAVE is the part of NFX open source framework that we released, and you can find somewhere around the video there is a link to GitHub site. Okay, but it is based, the WAVE server is based on the HTTP listener, but other than that, it has all of the pipeline and filters and handlers, everything we've built from scratch. We're not using IIS, we're not using ASP.NET, we're not using MVC or Owen or Nancy or any kind of the stuff, and we can achieve this performance just because everything is done in a very efficient way. So let me show it to you. Okay, here's the WAVE server. It is just a 54 kilobyte exe file. I double click it. I have my web server running. Okay, and how can we test it? Let's do this. Let's try to go and to the local host, and I'm holding my microphone in my hand because I need to shuttle back and forth between two workstations. But here is my test site. It's running on the local host, and it looks like crap, but it's a test site, so it should look like crap. Well, it doesn't have to, but I didn't have time to make it look pretty. MVC, I think I have a tester, and then that's one of the methods that I have. That's a full MVC framework. So what we'll be testing the full MVC framework with all of the filters, parameter binding, JSON serializer, and all of that stuff, guys. I'm not going to show you an HTTP handler. I'm going to show you the full freaking framework, the way how it works. And let me show it to you. Let me show you the code that I have. I have this tester controller here. Okay, just pretend for a second that this is Microsoft MVC. Okay, don't jump at me and tell me, no, we don't know what this is. So it's similar concept, right? You have a method, you have parameters, you have action. Okay, so here is another interesting guy. A random is going to populate the list of random numbers and just return the list. Okay, and a single random will return an object, and I think I have an echo that takes a complex JSON data map as an input. Okay, which is, basically atypical. It's a dynamic-like input that I convert. I just echo back an anonymous object with the server message, and I request data. I just echo back the data that came into my request. Okay, so let's see how it works. Now, I'm on the machine right now where I have a Skype session running. I'm logged into my another workstation, which is under the desk here. So I did it so you can see the screen here. Well, I'm going to invoke the Apache Bench program. And my server is Windows 7, as you can see, 64-bit. This is 64 gigs of RAM machine, but that's irrelevant because that's not going to take that much RAM anyhow. But it has 6 physical computers, or processors rather, with the hyper-threading capability. Okay, so that's why I see 12 little windows here. Now, let me tell you this. I am currently screen capturing when the Cam Studio, I think that's the icon, and that guy really screws up all of the performance. So the numbers that we're going to see, we have to really increase them by a good 25-30% if we want to be fair, because this guy kills the performance. Not only because of the CPU usage, but it does a lot of context switching. So, okay, let's do the test. So here's my Skype screen. You're gonna see my machine. This is my machine. I'm gonna move my mouse here. Okay. And I'm going to do, oops, I think my keyboard has just died. No, it still works. I have a USB keyboard. The batteries sometimes are weak. I'm going to do 50,000 requests to that server that I'm doing video recording on, but we're looking through the Skype screen share on the client machine right now. And I'm going to do MVC tester, and I'm going to do echo A0B23. I've done it here on the background so you can see what kind of response I get back. So basically I get your response back telling me the server message, blah, 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 and then I get my echo. I get this payload that I have supplied as a query parameters here. Okay, this is just to test how well the server performs. Okay, we're not testing any SQL. We're not testing anything. Just the WAVE server, our web server. Okay, let's give it a try, and here we go. 54,000 requests a second. Here is the number. I want you to see that. Now, I want you to increase that number by at least 15%. Well, usually 25, 30%. Just because Skype and all of the screen recording and all of that bloat that I have on top really screws or skews my performance towards the lower bound. Now, again, let me run this test again if you don't believe me here. Here we go. Okay? And this time we received, well, I guess it's a garbage collector, 21. Okay. The performance degrades. Let's do, instead of 50,000 calls, let's do 500,000 calls and see how that will fare out. And it's still working. This is an Apache Bench program, guys. I haven't written it. It's a standard Apache load testing tool. Well, to be fair, it doesn't really parse the response. It parses the HTTP headers. It doesn't parse JSON, but it does get the full request response cycle via the app. I have 56,000 requests a second. Now, I was testing some other stuff here. Let's do single random number. And I think I put here 8 million. That's just too much. I don't want to wait for another 5 minutes to finish. Let's do 750,000 requests with 64 concurrent connections. And if you wonder what the hell that is, this secret hello, that is just a, I put a stupid filter on my web server that filters out the traffic that doesn't supply a cookie with the name secret, and the value of the cookie has to be hello. Again, I'm testing my framework. Let's see how this works. And what a single random, we'll see, let it finish first. 64,000 requests a second. What a single random, come on. Okay, my keyboard is dead again. God damn it. Well, somehow it knows that I'm screen recording right now and it dies on me. Single random here. It returns a JSON object with a random number and the timestamp when it was generated on the server. Again, meaningless from the business logic standpoint test. But it is a meaningful task because it illustrates how the JSON serialization, how efficient it is, and how the whole filter and pattern matching pipeline on the server, how efficient that is, okay? And once again, I've been recording here from Skype, okay? Here is the Skype window, and here is my server, and where is my CPUs? Here are my processor on the server. Now I'm running test again and see what happens on the server on the CPU side. That's pretty good. This is pretty good. I got 60,000 requests a second. Okay. So if I turn off video recording session, if I turn off all of the screen capture and rather screen sharing with Skype, this number is going to be somewhere in the vicinity of 75,000 requests a second. Okay, if I serve a page if I serve a page, depending on the size of this page, just because the server has to push those bytes through the network, that is going to be the determining factor. If your page is small, the template rendering is extremely efficient as well. Well, actually, I can get to 100,000 requests a second here on this machine if I do very small payloads. But I mean, let's be practical. In the practical world, we're going to return some JSON payload. I think I have a case here where I return 100 random numbers here. I don't know if you can still see it. Yes, here. 100 random numbers. And let's try to run a test right now. Not the single random, but 100 random numbers. And let's lower this, because of course that's going to be slower. People say, oh, it's much slower. Of course, because you are pumping tons of bytes, just physically pumping those bytes. 50,000 requests a second. Here we go. Here we go. No, that's 50,000 requests total. And right now we fared at around 9,500 requests a second. But keep in mind, every response was 6.6 kilobytes, 6,600 bytes. And the total HTML transferred was, 335 megabytes of HTML content. So that's not even processor. That's a lot of traffic. Look, the gigabit Ethernet switch is loaded like 50% for the duration of the test. Okay? So, and I think I can also say question mark 2, instead of 100, let's do 24 numbers or something. And that's going to be much faster. And I'm at 27,000 requests a second. Here is the number right here. Why? Because I have only pumped 80 megabytes of information right now. Just because I have reduced the number of, it takes two parameters, from and to. I have reduced the number of random numbers that I want my server to generate. So, to summarize what I've shown to you today is this. We have tested a very high level MVC framework that has a lot of filters, security permission checks, routing, and pattern matching all embedded here. So we're not testing just an HTTP listener, bare bones. Please compare apples to apples. Do not tell me, guys, that some of you have done a better test with a socket. This is not what we're testing here. We're testing here a full HTTP solution, okay? And then we have tested a number of methods that return, well, here is the single random method. It returns an object and an anonymous C# type that has a random integer and the timestamp. And we have tested this guy as well, okay? And we have determined that for simple responses like this, the pipeline easily on this machine, which is 3 gigahertz, i7, Core i7 running Windows 7, I'm running a server on the Windows 7 machine, I can achieve, if I have a screen capture, what did we get? Like 60,000, I think, requests a second. And if I don't have all the screen capture and Skype screen sharing, I can achieve on this machine 75,000 a second on the stable vicinity. But sometimes I can even go, if I make that, if I don't return JSON but return a string, that of course will become even faster, because now you don't even need to serialize that class as a JSON. Okay, so but here you have it. Again, let me show it to you on the big screen. For those of you who don't believe me, here is the payload, which is 1 kilobyte in size, and I have 28,000 requests a second. Let's make this payload smaller, and I have 49,000 requests a second with extensive JSON serialization and a lot of 54,000 now, okay? And now let's do a simpler object. Single R&D will return a simple object, which is only 69 bytes. And I'm at 60,000 requests a second, okay? And I can run the test multiple times. And I've been running those tests for nights and days long, for weeks. Actually have pretty high electricity bill here as well. Well, like $24 more a month, I think, for running those servers night and day, running those tests, which is not bad. But I have multiple servers here. But you see the results, and the server is available at GitHub, code NFX under WAVE. And here is my server process, and I'm just going to terminate it now. Okay, it's done. If I want to run my web server, I just double click on it. Here it is. There is no such thing as a web server. It is just a console app. I just clicked enter again. And it's just a small app. And this is just a test rig that has tons of different high-level stuff here that I tested, and like captcha controls, and all of that stuff. But if you want to look at this, the test site at the program, it is just a service-based application container. We allocate the WAVE server. We configure it from the root. We start the server. We block until someone hits enter. And then if exception happens, we just dump it with exit code -1. That's it. That's the web server. The configuration file for it has a logger here, has all kinds of standard NFX stuff that we are testing here. But we have a server here. We have a gate, which is a software firewall that we have integrated in our server that allows you to filter out the traffic for those guys who want to do a session flood with us or something like that. They're not going to get a good result. They're going to get access denied, and they're not going to get any response, actually. And we can do it on the application level. This filter works past the hardware filters, okay? And as far as the filters in terms of like error filter for showing error pages, block non-devs, here is the thing: if this cookie is absent secret hello, then I get the error or something. I redirect to MVC tester secret or something like that. There's just a filter just to see how redirection works with the cookie filtering, okay? I've got a session filter here. I've got a filter for some old redirect, some pattern matching. What used to be this should be this now. I've got some context dumper embedded site that I can embed right here in the resource. Here I can embed my whole website if I want to as the resources right here. In some cases this is very useful. And where was I? Here I was in the laconic configuration file, I think. Okay, and then for my pages, I can serve pages, okay, just like you do with Razor or something. We don't use Razor, we use our own template engine. It's all in the NFX. You guys have full access to that source code. The geolookup filter is an awesome thing. It turns the IP address into physical location if it can match one, okay. This stuff is based on the MaxMind. You go to maxmind.com or something. It's a free database. You don't need the paid version. They have a free version. You download a 200 megabyte file, and this service parses it and allows you to inject the geolocation automatically in your context when you execute your HTTP requests. The stock content embedded side, those are some stock system like fonts and JavaScript and all of that stuff. Security checks, the stopper. If someone has the word Lenin in the request, we are going to stop Lenin and not allow him to access the site. This is an absolutely bullshit match here, the pattern match that I do, but this is just for testing. Okay, the stopper filter is used for some specific cases I needed it for some application. It's not a generally used filter, everyday filter that you would use every day. Anyhow, it's here just for the speed test. The logger, you can log stuff in the log. So the requests come through all of that crap, through all of this pipeline. You see how much stuff I have purposely put here. The file download handler, I'm mapping that to those local drives, local drive location, and here's the place on my drive, and I can serve files from my root/download/file path is going to be prepended here. This is for cases when I need to serve some like static content from the Wave site. Now, let me tell you, Wave site, it's an application server. It's not purpose for static because we usually have it behind Nginx or something like this, okay? That runs on Linux, and it caches the static content, but it feeds that static files like some static CSS. Well, these days everything is pretty much dynamic, okay? But sometimes you have some static files, so why not just throw them in there? It will serve it to you. Okay, catch all. It finally trickles down here, and it shows you the page is welcome. So the reason why I show this stuff to you is just to show you how much pattern matching all of that processing pipeline has. So if I remove much of that stuff for the purpose of my test, I'm going to get over 100,000 requests a second. So those numbers that I showed you, that some of you guys accused me of being a liar and bullshitter, that stuff is actually that's a full loaded pipeline of the actual similar to the actual production application. Okay, if I wanted to rig these numbers, I would have just removed all of that stuff and the numbers would have been higher. But other than that, that's pretty much explains how this stuff works. Here's my server back and running, and here are the pages. I was testing some multi-part parsing. The framework does all of that stuff, and all of the JSON, all of that stuff is here, and all of that UI is built from the metadata in your C# code, and we can translate stuff dynamically. You see I use some Russian captions here that come from the translation pack files. You can put translation in config file. You just say this in English, that string is going to look this in French, and that in German, okay? And you can key that and just keep those config files on the server and swap them, and if you put more translations in. And this is the captcha control that is also part of the framework. It's embedded. You don't have to use it. You can use whatever you want, of course, but this one is embedded here, and we can talk about it some other time. But other than that, that concludes that little demo that I wanted to do. Thank you.